Next is derived gates. So derived gates are constructed. Derived gates are constructed by combination of derived gates are constructed by combination of two or more basic gates So derived gates are constructed by combination of two or more basic gates, the NAND gate, then the NOR gate and XOR gate are the important derived gates. The NAND gate, NOR gate and XOR gate are the important derived gates. Next we will see the first derived gate, that is NOR gate. So see here, NOR gate has two or more inputs and only one output. So NOR gate has two or more inputs but only one output, and this NOR gate is constructed with an OR gate followed by NOT gate, or we can say as inverter, followed by an inverter. So the NOR gate is constructed with OR gate followed by NOT gate or an inverter. Now see here, this is the logical meaning of NOR gate. That means the NOR gate is constructed with OR gate here followed by NOT gate or an inverter. So see here, this is the OR gate here and this is the NOT gate. So OR gate followed by NOT gate. So this combination of OR gate followed by NOT gate is the NOR gate here. It is the NOR gate. Now next we will see the symbol for NOR gate. Now see here, this is the symbol for NOR gate, and this symbol represents here A and B are the two inputs and Y is the output of this NOR gate. So this is the symbol for NOR gate which having two inputs. So this is the symbol for two input, one output, NOR gate. Now see here, this Y is equal to A plus bar. This is the Boolean equation. For two input NOR gate. So in this Boolean equation, this plus sign indicates the OR function, and this bar, see here, this bar is the inversion of OR. So in this Boolean equation, that is Y is equal to A plus B whole bar. In this Boolean equation, this plus sign indicates OR function and this bar indicates the inversion of OR. Next we will see the logic behind this NOR gate, behind this two input NOR gate. The logic behind this two input NOR gate is, if input A is true, input A is true or input B is true, then the output Y is false. Output Y is false. It means that if input A is high or input B is high, then the output Y is low. So if one of the input in this two input NOR gate, if one of the input is high, then the output is low. So when the output of this two input NOR gate is high, when both the inputs, that is A and B, are low, then and then only the output of two input NOR gate is high. So see this truth table. See this truth table for this two input NOR gate, in which A and B are the inputs and Y is the output. So as there are two inputs, so there is a four possible combinations: 0 0, 0 1, 1 0 and 1 1. Now see here, in the first combination both the inputs are low, then the output is high. In second combination, one of the input is high, output is low. In the third combination, A is high, B is low, output is low. In fourth combination, both the inputs are high, then output is low. So this is the truth table for NOR gate, truth table for two input NOR gate. Next we will see this simple circuit for NOR gate using switches as input and LED as output. So see here, this Y represents the LED here and it is the output here, and these two A and B are the switches which are used as a input here, and this is the DC power supply here. Now we can write here the truth table. We can write the truth table for this simple circuit of NOR gate. Now see here, we are using switches as input here, so A and B are the inputs here. A and B are the inputs, and this LED, that is Y, as output here. Now the first combination is, if switch A is open, that means binary 0, and switch B is open, that means it is binary 0. Now both the switches are open here, so there will be a no current flows through these two switches. That means the current will directly flow through this LED, to the negative terminal of battery. So as the current flows through the LED here, then LED will glow, that means it will gets on here, so it will be represented as binary 1. Next combination is, if switch A is open, that is binary 0 here, and switch B is closed, that is binary 1. Now if switch B is closed here, so the current will flow from a positive terminal of battery from this switch B, from this resistor to the negative terminal of battery. So here there will be a no current flows through the LED, so LED will not glow, that means it will be off, so it is represented as binary 0. Next, if switch A is closed, it is represented as binary 1 here, and switch B is open here, so it will be binary 0. So if switch A is closed here and B is open, that means the current will flow from positive terminal of battery from this switch A through this resistor to the negative terminal of battery. So there will be a no current flows through the LED, so LED will not glow, so it will be off here, so it is represented as binary 0. Next is, if switch A is closed, that means it is binary 1, and switch B is also closed, so it will be represented as binary 1 here. So see here, if both the switches are closed here, that means there will be no current flows through this LED, so LED will not glow, that means it will be off, and it is represented as binary 0. So this is the truth table for the simple circuit of this NOR gate using switches as input and LED as output. So this is all about the first type of derived gate, that is NOR gate. Next we will see the second type of derived gate, that is NAND gate. So this NAND gate has two or more inputs, but only one output. So NAND gate has two or more inputs but only one output, and this NAND gate is constructed with an AND gate, followed by NOT gate, or an inverter, So the NAND gate is constructed with an AND gate followed by NOT gate or an inverter. Now see here, this is the logical meaning of NAND. Now see here, this NAND gate is constructed with an AND gate. See here, this is AND gate here, and that AND gate is followed by the NOT gate. So this is the logical meaning of NAND gate. Now next we will see this symbol for NAND gate. See here, this is the symbol for NAND gate, and this is the symbol for a two input NAND gate in which A and B are the inputs here and Y is the output. So this is the symbol for a two inputs, one output NAND gate, and this Y is equal to A dot B bar. This is the Boolean equation for this two input NAND gate, in which this dot represents the AND function, and this bar indicates the inversion, of AND. Bar represents the inversion of AND. So this is the Boolean equation for two inputs, one output NAND gate. Now next we will see the logic behind this NAND gate, behind this two input NAND gate. If input A is true, and input B is true, then the output Y is false. So if input A is true and input B is true, then output Y is false. That means if input A is high and input B is high, then output Y is low. Next we will see the truth table for this 2 input NAND gate. Now see here, as there are 2 inputs, so there will be 4 combinations here. First one is 0 0, 0 1, 1 0 and 1 1. So according to logic, if A is high and B is also high, then output Y is low. So see here in the 4th combination, that is A is 1 and B is 1. That means A is high, B is high, then the output Y is low. That means it is 0. And if one of the input, that means either A or B, is low or both the inputs are low, then the output of this NAND gate is high. So see in the first 3 combinations, the input A and B are low here. So in the first combination both the inputs are low, output is high. In the second combination input A is low, output is high. In the third combination input B is low, output is high. But in the 4th combination both the inputs are high, because of that the output is low. So this is the truth table for NAND gate. Next we will see the simple circuit. Next we will see the simple circuit for NAND gate using switches as input and LED as output. So see here, these A and B, these are the 2 switches are used as an input here, and this LED as output. Now we will write here the truth table. We will write the truth table for this simple circuit of NAND gate using switches as input and LED as output. So we will write here switch A and switch B as an input and LED Y as a output. Now see here, first we will take the first combination, that is if switch A is open, that means binary 0, and switch B is also open, that means it is binary 0. If both the switches are open, then what happens? The current will flow from positive terminal of this battery through this LED, through this resistor, to the negative terminal of battery. So as the current flows through the LED here, that means the LED will get on here. So it represented by binary 1 here. So as switch A is open, switch B is open, no current will flow through these switches here. So all current will flow through the LED and the LED will get on here. Now we will take second combination, that is if switch A is open, that is binary 0, and switch B is closed, that is binary 1. Now if switch B is closed here but switch A is open, that means the current will not flow through switch A. So as the current will not flow through switch A, it will not flow through the switch B. So all the current will flow through the LED, through this resistor, to the negative terminal of battery. So LED will glow, that means the LED will get on here. So it will be binary 1. Now we will take the third combination, that is if switch A is closed, so that is binary 1, but switch B is open, that is binary 0. Now see here, switch A is closed here but switch B is open. So the current will flow through switch A, but it will not flow through switch B. So because of that, it will not flow through this path here. So because of that, the current will flow through this LED. Current will flow through this LED, through this resistor, to the negative terminal of battery. So the LED will get on here. So it is represented as binary 1. Now we will take the fourth combination, that is if switch A is closed, that is binary 1, and switch B is also closed, that is binary 1. So as switch A is closed and switch B is closed, now the current will flow from positive terminal of battery through this switch A, as this switch is closed, through this switch B, through this path here, through this resistor to the negative terminal of battery here. So when both the switches are closed here, then the current will flow through this path that is shown here with this yellow line. So there will be a no current flows through this LED, so LED will not glow, so it will be off. So it is represented as binary 0. So this is the truth table for the simple circuit of NAND gate, and this is all about the second type of derived gate, that is NAND gate.